Okay, section 6.2 deals with all application problems and exponential models. We're going to look at two new types of models today. So one is going to be compounding interest, and then the other will be compounded continuously. So for a general exponential model, or the same setup we talked about the other day, where a equals p, 1 plus or minus r. This time, though, instead of just going like years, we're going to have an exponent of t over k, where t is going to be our time in years, and k is the number of years that have gone by, or the number of years for a period, compounding period. So what that would look like, example 1, I want to write an equation that can be used to model the population of carp in a pond. Our initial amount is 200, so that's going to be our P. That's the initial amount up front. It says the number of carp will increase by 0.3%, so that's R, every 4 years. So that's going to be K. So to write our equation to represent this, it's going to be A equals, we have our initial amount of 200. It's going to grow, so we got 1 plus, and then 0.3%, we have to switch to a decimal. So that's going to be 0.003. We're raising it to the t over k power. In this case, k is going to be 4, because every 4 years, the compound is going to happen. Okay. So from there, if you want to figure out the population after a given amount of years, so let's say we wanted like 12 years, you'd plug in 12 for t, and then whatever the equation or function kicked out, that would be your population for the carp. Compound interest, for example 2, is really the main focus for today. So compound interest, there's different amounts of periods that we could have for our compounding interest. The common ones are up here in this box. You have monthly, weekly, daily, quarterly, biweekly, semi-annually. Those are going to be our n value in this formula. So whenever we talk about compounding interest, we're going to be using this formula right here. So P is still our initial amount invested. R is going to be our rate as a decimal. And then N is the new one. So that's the number of periods in a year. So if we're going daily, N would be 365, quarterly would be 4, so on and so forth. A is the amount that we have after the given amount of time, and then T will be how long this has been going on in years. So we're going to set up these functions or equations down here for different scenarios. So you have Tamara invested $5,000 in an account and pays 4% annual interest. I don't know how much will be after 3 years for the following scenarios. So P is our initial investment, 5,000. Our rate is going to be 0.04. And then we're looking after 3 years. So our T value on this one is going to be 3. N is going to be dependent on which scenario we're going with. So if we're going annually, that'd just be yearly. Our N value would be 1. Semi-annually would be twice a year. So N is going to equal 2. There's 4 quarters in a year, and then there's 12 months in a year. It's the only thing changing as we go down is the N value. So from there, if I go ahead and write my functions, first one would be A equals 5,000. And then we got 1 plus 0.04, divide 1 to the NT, so it would be 1 times 3. Our next one is semi. So again, like I said, the only thing changing in this setup is the N value down below, okay, because we're using this formula up here because it's talking about compounded. Okay, so you see compounded, we're using this formula up here. So semi-annually, we'd have a 2 in the denominator, and then my exponent would be 2 times 3. Quarterly, is going to be a 4. And then monthly, we're going to switch to 12. The reason these all have 3s is because we want to know the amount after 3 years. Outside of that, only thing changes the N value. So I want you to go ahead and actually practice typing this in on your calculator. So if you have a graphing calculator, use it. If not, remember on your phone, the app you could use is Calculate 84. But you definitely want to become familiar with plugging this in. So doing that, it's going to be 5,000, parentheses 1 plus 0.04 divide 1, and then we are raising it to the 1 times 3. Okay, you need to make sure you're typing in exactly how it looks on the page. We go ahead and hit enter, and since we're dealing with money, this one I don't have to worry about, but we are going to be going to the second decimal place. Okay, so annually, we should have got that right there. Semi-annually, we're going to have 2 and 2. So it should be 5,630. And then this is what I was talking about. We need to make sure that we go to the second decimal place because we are dealing with money. So 5,630.81. We go back. Next one, we're going 4 and 4. So it should be 5634.12. And actually, that would round up. So $5,634.13. And then our last one, we are going monthly. So we have the same setup, just changing our end values. So it should be 12. And then we got 12 times 3 up top. So 5,636 and 36 cents. Okay. So that would be for compounded interest, just straight compound. The key to the problem is finding n. Okay, so how many times is it being compounded per year? We also have a special type of compound interest that is called compounded continuously. Okay, so if we have continuous compound interest, pretty much they're telling us that it's constantly happening. Okay, so it's happening more often than like daily, hourly, secondly, minutely. Like it is constantly happening. As soon as you see the word continuous, and we are having compound interest, the formula I like to use is it's A equals PERT. That's how I like to refer to it. So P is still the principal amount in there. E is our natural base. It's an actual number. Okay, so it's much like pi. It's just a number. Okay, that we're working with here. And then we still have rate and time like the other ones. So one example of that before, we got Regina. She invested $12,600. So our P is 12,600. 3.2%, so our R is 0.032. Compounded continuously is the key. As soon as you see that, we know our formula is A equals PERT. So really, there's just one more thing we need, and that would be the time in years, which is 12 years. So plugging in, it's going to be A equals 12,600 E to the R times T power. Okay, so there's your setup right there. It's calculator time. All right, depending on what calculator you have, the E is going to be in different locations. On the graphing calculators and on Calculate 84, it should be in the same spot though. So it's going to be 12,600, and then we want E. There's two spots you can find it. Personally, I like to use the one that already kicks it into an exponent. So on the left-hand side, if you hit second ln, it's going to give me E, and it raises it to an exponent. So from there, you got 0.032 times 12. Okay, so 12,600 E to the 0.032 times 12. Hit enter, and it's going to give me my answer. For this, they want it to the nearest dollar. So to the nearest dollar, just going to the nearest whole number, we would be rounding up to $18,499. And that is it for section 6.2.